All right, y'all. Today we're going to be talking about what we call double distribution. Double distribution is a way for us to multiply polynomials. So last week we were adding and subtracting polynomials. This week we're going to add in multiplying polynomials. So we're kind of going up in difficulty of our operations. So when multiplying polynomials, we are essentially using the distribution property twice. This is why we call it double distribution. We follow a few simple sets to distribute, which means multiply. Correctly. So we're going to look at the following example. So example 1, we're going to multiply x plus 2 and x plus 3. So notice that there's not a multiplication symbol between them. There's just a set of parentheses. But we know parentheses mean to multiply. But since we have the 2, we're going to be multiplying everything in here by everything on our second set of parentheses. So our first step is to distribute the first term in the first set of parentheses to each term in the second set. So if I have x plus 2 times x plus 3, then I'm going to take this first term, x, and I'm going to multiply x to x and x to 3. So if I do that, that would give me x times x is x squared, and x times 3 is 3x. Okay, so that's the first part so far. Now my second piece is that we're going to distribute the second term in the first set of parentheses to each term in the second set. So we've already distributed our first term. We still have x plus 2 times x plus 3. We already got our first piece to be x squared plus 3x. So now we're going to take this second term, 2, and I'm going to distribute 2 to x and to 3. So 2 times x is 2x, and 2 times 3 is 6. Then our very final step, so once we have completed our double distribution, we want to go ahead and combine any like terms to simplify our answer. So what like terms do we have? Well, we do have 3x and 2x that are both x's. So 3x plus 2x would be 5x. So we would get x squared plus 5x plus 6. So something you should notice is that we have now gotten a quadratic formula, specifically a quadratic formula that's in standard form. And if you remember from what we talked about earlier in the year, this is a quadratic function in factored form. So we went from a factored quadratic function to a standard quadratic function. Okay, so that's a skill of double distribution. That's what we're learning how to do, is essentially convert between factored form and standard form. So let's look at some more examples. So example 2, we have x plus 1 times x minus 4. So our first term, we're going to multiply by each term in the second set. So that gives me x times x is x squared, and x times negative 4 is negative 4x. Then I take my second term and I multiply it by everything in the second set of parentheses. So 1 times x is x, and 1 times negative 4 is negative 4. Then I take any like terms, so negative 4 and positive 1x, and go ahead and add in that 1 so it's easier to combine my like terms. So negative 4 plus 1, we're going to subtract. So 4 minus 1 is 3. And then we keep it negative because the negative is bigger. So we get negative 3x. X squared minus 3x minus 4. just like so. Now looking at example 2, or example 3, we have 4a plus 1 times 2a minus 1. So we got some coefficients in front of our a's, but that doesn't really change anything. It just means we're going to be multiplying by both the a term and the coefficient. Okay. So I take my first term, 4a, and I distribute it to everything in here. So 4a times 2a, 4 times 2 is 8. A times a is a squared. 4a times negative 1 is just negative 4a. Now I take my second term, the 1, we distribute it to 2a and to negative 1, and anything multiplied by 1 is just going to stay the same. So this becomes 1 times 2a is 2a, 1 times negative 1 is negative 1. And then we only have one set of like terms, negative 4a and 2a. Negative 4 and positive 2 gives us negative 2. And then everything else stays the same. So each time we should go from a factored form to a standard form. All right. Now, example 4. Example 4 looks a little weird. We have 5x minus 3 squared. So we don't have two sets of parentheses. But we can change this one to make it into what we're used to. So this is the same as, because I'm squaring something, a square means to multiply something by itself. So 5x minus 3 squared is the exact same thing as 5x minus 3 times 5x minus 3. So anytime we have a square or a cube or something like that, it just means to multiply that base that many times. So we're multiplying our base 2 times, so that's why we're multiplying, and we have 2 sets of the base. So 5x minus 3 and 5x minus 3. Now we're going to do our double distribution just like we did before. So 5x distributed to 5x and negative 3. So that gives us 5x times 5x. 5 times 5 is 25. X times x is x squared. 5x times negative 3. 5 times negative 3 is negative 15. So negative 15x. Then we take our second term, so negative 3, and I'm going to distribute it to the 5x and the negative 3. So negative 3 times 5 is negative 15, so negative 15x again. And then negative 3 times negative 3 is positive 9. So we get positive 9 down here at the end. Then we do still have a like term in that x term, so 15x and 15x. We're going to combine that. They are both negative, so we add it together, keep the sign the same. So 15 plus 15 is 30, so we get negative 30x. And then everything else stays the same, plus 9 and 25x squared. So you should start to kind of notice some similar patterns, similar steps for each of these. All right, our last one, example 5, we have n plus 1 times n squared plus 4n plus 5. Hey, so now our second term, it's no longer a binomial, which is a polynomial with only 2 terms. It's a trinomial. Okay, it has 3 terms. Now, this seems a little bit tricky, but all it means is instead of doing double distribution, we're going to do triple distribution, because we are going to distribute that first term to all 3 numbers inside the parentheses. So distribution always works the same way. We always distribute to everything inside the parentheses. So just because we have more things in the parentheses doesn't mean it's going to throw anything off. Okay, so we have n times n squared. N times n squared is n cubed. N times 4n is 4n squared, because we have 2 n's now. N times 5 is 5n. Then we take our second term, positive 1, and we are also going to distribute it to everything in the second set of parentheses. So 1 times n squared is n squared. 1 times 4n is 4n. And 1 times positive 5 is positive 5. Everything just stayed the same because we're multiplying by 1. So now we can go ahead and combine any like terms that we have. So we have 4n squared and n squared. So 4n squared plus, that's 1n squared. So 4 plus 1 is 5. So we do get 5n squared. Then we also have positive 5n and positive 4n. So positive 5 and positive 4, those combine to get positive 9. And then everything else stays the same. 5 is just 5, so plus 5. N cubed is just n cubed, so we get n cubed. And there you have it. So we ended up with one extra term. We ended up with this n cubed term that we hadn't had before because of the extra term in our polynomial. All right, y'all. So that is double distribution. It's pretty straightforward. I know this is new and, kind of difficult, but just do your best this week. You have the quizzes coming up next, so make sure you practice through the quizzes. You can do it multiple times if you need to until you feel confident, and then take the self-assessment at the end of the week. All right, thank y'all.